other viewers from various parts of the world. And it gives me a great pleasure joining you on this meeting because, as I know, you are one of the fundamental research institution engaged in pharmacology. As you are aware, when I started my career into IT in India, my first challenge was the supply chain issue, which was on drug management. In fact, when I went into this, it was an accident. After my long stint in the US, I came back to India in 96, 94. The Tamil Nadu and the rest of the India has a very poor drug supply chain management system. Largely, they all depend on human interfaces and completely manually driven system. So given this situation, there were a lot of corruption, there is no transparency, and there is no efficacy of medicine, and there is a complete chaos. At that state, our chief minister requested that since I worked previously with the World Bank, she thought I will know systems better. She requested me to devise a system. Then I entered upon doing a comprehensive supply chain system. Today, let me start about my experience and go into the technology. You can all see a drug logistics presentation here. So this is what I devised. This is just to, to make everything transparent. What happens in the beginning, those are times we don't have a clue. I hope all of you can see the slide, right? The logics.
Yeah, it's
you all
visible.
see that?
Yeah, it's visible.
Okay, wonderful. So this particular thing, when I was approached by the government, I just have to do something to set things all right. I went around to visit various hospitals and district, centers, medical centers, tertiary hospitals, primary care, primary health centers, and so on. I found largely there is a huge problem of supply chain. As you all know, today, supply chain is the most important concept in the manufacturing and distribution of medicines and any commodity for that matter. So I was just going around and found that there is no proper quantification of what is required for the patients and what is being procured. There is a big difference between what is needed and what they procure. So first thing I wanted to address that. So I found there is a lot of requirement in certain drugs which are not in stock. There is no big requirement. There is a huge procurement. So what I understand, they don't have a scientific method of forecasting. So forecasting is a very, very important concept. Unless you forecast what you needed, you will not be able to procure the right quantity. So what I did, I just gathered various consumptions from hospitals. When I went to look at the hospitals, it's all written in manual form, and then I found these manuals to be converted into digital format would take a longer time, so I'll not be able to do that. So what I did the overall requirement of budget, how much of medicine being procured required for each of these hospitals. From the medicines, I divided various class of medicines and trying to quantify approximately for a year in each of these drugs. So this is the quantification. That's a very rudimentary and uncertain, but that's the only way I can do that. So I have studied the quantification. So after going through that, then I found the procurement is absolutely in chaos. Drugs were procured, about 3,500 drugs have been procured. In the, as you are aware, there is no SQL drug list has been followed. So it was just procured on their own wish. See, same drug procured at different names. So what happens here? There is no rationality in price. There is no rationality in size. There is so many in strength and so on. And then there was one more point I was very visible was procurement has been done in containers. So glass containers, the drugs have been stored and has been kept. And the pharmacologist will, the pharmacist will just put his hand, pick up medicines and give to them. And the poor people, they don't know how to carry these medicines. So this is another problem. So various problems I analyzed. I came back and then I presented before the Chief Minister the problems. A, there is no quantification. B, there is absolutely no connect between what they need and what they procure. And number three, they didn't have an overall view about what drug is required and how much quantity they need and so on. So then I also started to observe these drugs are not being procured properly and it's in haywire, and there is no rationality in drug procurement in the sense they are not following the a typical essential drug list. So then I have told them these drugs, once you procure, you need a warehouse in each of the districts to keep the drugs safely, and then it should be distributed to all the hospitals. But having said this, they just left it, and they were all very keen to know that they're all very keen to know particularly how these can be made. So I told them there is the only way we can make this system to function. We have to bring in about overall computing. It should be based on computers. So she wanted a report. Then I gave a report which comprises of drug procurement, quantification, procurement, then the bill processing, then the supply monitoring, then warehouse management, quality control. This is another important aspects I brought in. Then the drug passbook and the pharmacy management and stock control, then the payment to the vendors. All this I encompassed and presented to her. Having presented, the Chief Minister was very quick to comment. He said, presentation is of no use. There are many presentations I have seen. I want a system in place. Then I worked on the system. Within about 6 months, I was able to implement this drug logistics and supply chain system in Tamil Nadu in '94. This has become a model for the whole country and several parts of the world. Today, this system uh, has been implemented entire India. All the procurement is based on TNMSC model or the drug logistics what I did in Tamil Nadu. Now coming back to this, the system per se, see actually when we are going for procurement of a drug, you should know quantification is done. Then the tender document should be very transparent. What happened earlier when we procure a drug, we just would say the quantity of drug and the strength of the drug, and the people were quoting haywire. I mean, different pricing because they have given 12 tablets in a strip. Some people give 10 tablets in a strip. When I ask for a strip, 12 tablets will be higher than the 10 tablets, so he will become L1. So there are a lot of complications. So what I did, I rationalized the size of the drug, I mean the strength of the drug, and the packing of the drug, and the quantity of drug. All the vendor has to quote is just the price of the drug. Then everybody quoted. Then one more thing I did. When first time I'm inventing a drug, the people who have got greed, they may quote 500 mg, but it will be only 400 mg or 350 mg, or they may include something else to just meet the quantification. So what I did a basic working on how much a drug is cost to manufacture. So based on the cost, I fixed the minimum price. So anybody quoted below the minimum price, I eliminated them. So all the spurious drug manufacturers, all the fake fellows who have been supplying the government have been eliminated through this process. So first time in the country, we introduced the e-tender process. What we did is all the people who submit the code, we were asked to them to supply. Those are days we don't have much of a powerful internet, or we don't have any pen drive. So all we used is a floppy disk. They have to submit the code along with a floppy disk. So the floppy disk, we put it on the system and loaded everything, and then we displayed the summary of the drug, price, quantity, etc. on board, and the L1 takes the order and walk away. If the L1 may not be huge enough to supply us, then we have taken L1, L2, L3, to match the L1 price. And this is the first transparent tender procurement process we have done. Once done the procurement process, we have not gone for a full year, we have just gone for half year. Half year procurement we have done. And by then, we have located every hospital as a special place for storing the drug. So, district headquarter hospital, we have created a special place to procure the drug. Then I requested the uh, chief minister and the secretary to build various warehouses. We started building warehouses in each of the districts. So each district had a clean warehouse. The warehouse was made in such a fashion that it forms entire international requirement. It is one of the best warehouses even today. What we built in 94 and 95 stands good even today. We built such a beautiful warehouse in all the district quarters. By then, the procurement arrived. We started moving the drugs to various warehouses. And in the warehouses, I used pallets and tracks so that the drugs moves into the right place and it is being taken away very well. While dispersing drugs from the warehouses, we have used first in, last out. See, first in, first out. We don't use first in, last out. So we could manage all that in a computational power. So every drug that we procure from this various vendor that has been stored well, and in the storage system, we also built in a automatic walk-in cooler and various cold storage facilities where we stored all the drugs which needs proper thermal protection. So that has also been taken care. While fetching the medicine out of this warehouse, I mean various racks and pallets and so on, we were easily doing it because we were not much worried about the manual operation. Everything was automated by then. Our computers will say where the drug is stored and which pallet should be moved out to take. So they move the forklift, take the pallet out, pick up the drug and start giving. Then what I introduced was the supplier monitoring. See, suppliers, once they give an order, they promise to supply within 3 months, but they will try to exceed. So there is a supply monitor. So if we used to know when the supplier starts from there. If it is manufactured, when are they moving? Where is the go down? So we were monitoring their logistics route. So we are very sure when the drug will come. In case if a drug is not coming on time, in some warehouse it is needed, we have also made automated warehouse to warehouse transfer. So it is so brilliantly we planned the warehouse to warehouse so that we have ensured there is no drug, drug out situation in any of the warehouse or hospitals. So here is one point I must make to all of you. This after the implementation. Before the implementation, we were spending about 300 crores and we were not able to meet 30% of the requirement of patients. After the implementation, we have improved in terms of cost, we have reduced. We have reduced from 300 crores to about 260 crores. We saved 40 crores in terms of procurement costs. Whereas serviceability to the patients have grown from 30% to 92%. That was a phenomenal exercise we could achieve in the first year of implementation of drug management system. So the supply monitoring, we were able to understand and fix the supplier. The first year itself, we know who are the right vendors, who all are very reactive, whether, and another major problem we observed was the quality control. What I did, any drug which comes from these suppliers are put in directly for checking its quality. So quality control goes into, it's again a very difficult system to break. What we did is drugs are picked up from various batches and it is kept, strips are removed, and we used to make only a kind of barcode and we paste it on top of it. So nobody knows which company drug, where it is packed, where it is going, because once the people are aware of it, they will go and influence the labs. So we have chosen random labs and we started moving the drugs at random centers. So we were able to get the best, report out of them. Based on the report, we were able to manage our drug, efficacy and its, usability. So we ensure because of the quality. Then what happens? We have got another issue. How is it the hospitals should draw? So each hospital we have fixed a budget. So that budget we have given a drug passbook. The drug passbook we have given to each of the hospitals, whether it is a tertiary care or a primary care, they were given a passbook. So carry the passbook. They'll come back to our drug center. They will ask us what to be done. Then we give them whether that's okay. I mean, whether this amount of drug can be given, whether they have consumed the drug last time. Everything we could monitor through the passbook. So passbook has given a beautiful link between the user and the system. So again, over a period, we started giving computer network to these government hospitals. So they know what they are drawing, what is that they are lacking, which drug is going out. If the moment we understand few hospitals running out of a drug because of any epidemic or on account of any other issues, we try to replenish these hospitals. We will give extra sanction to this hospital because epidemic those days we don't see in entire go downs. Happens in one district, may not happen to the other districts, but other districts that drug may be in stock. So we move it until we procure the stock. So this passbook system gave a transparency of every hospital functioning. After the implementation of this drug passbook, we were able to observe a huge error in terms of many doctors not going into the hospitals. Many of the primary health centers, we found 6 months they have not taken any stock of medicine. They were very casual. So we were able to call out those hospitals and we started making inspection. So that has improved the moral of working. So hospitals, doctors will be present. Morning they have to be present. They have to see the patient and they have to draw drugs from us. So we were, through the drug consumptions, we were able to manage the hospitals comfortably. And overall, we got a clear picture what kind of drug consumption, what is that needed for the next year. See, we started working on the analytics. We have gone into deep analytics. We were trying to build various analytical, papers and all that, and we have forced everybody into a finest, clutches. So hospitals were not trying to play around, and the doctors were able to, do their work, and everything which came under a one-page statement, which I was extending to the health secretary of the state. So then it moves on to the CM. So when the moment in a one-page management starts moving in, everybody become very accountable, and the hospital function starts improving. And at the outset, we were able to achieve a wonderful result out of this drug logistics. This is the overall drug logistics and supply chain management we envisaged in 1994. But then this drug logistics and supply chain has become so popular. It has become so popular in many of the states, and today it is implemented entire India, and it's also going through multiple countries in the world. And Tamil Nadu has become a mecca of visits. Many of the hospitals, many of the large cities and mayors and state heads are visiting us and trying to understand what is drug management system is all about, and they are implementing. One good news is I started to advise them free of cost in multiple countries, and I have East Timor we were able to implement. We were able to implement in Indonesia. We were able to implement in many South Asian countries, as well as we had the opportunity to bring it to Africa and so on. So this is overall become a very great success. So at that point in 1994, whatever computational power we used, whatever MIS we built, whatever pharmacy management we brought in was all very simple. I mean, the computational power is about 60% and 40% is the monitoring of various people. And now what happens, the whole system has revised. It has become more on a more than human intervention. It becomes all through the IT and so on. That is the technology difference which I'm going to speak now. If you look at this where these 5 stages of disruption, this is very interesting. If you look the olden days, as you are aware, the Kodak was one of the largest company in the world. During 90s and 2000, a company which can never die, which is one of the largest company and such a fortune company, and which was present in the list of 500 fortune company and 100 fortune company. Such a beautiful company because the company was so self-reliant. They sell cameras, they make film, they make development, they print end-to-end solutions. Only company which was widely known was Kodak. Kodak was America's one of the greatest companies. But what happened to Kodak? Kodak, when the digital technology came into existence, Kodak was not adapting. They were going with their manual pictures, manual development, and they were not adapting to digital. You know what happened? In the year 2000, around, the company was insolvent. The company was closed. Why? Because the technology adaptation was not being accepted. Same, there is another disruption which we all seen. When I was in the 90s, I used to see the late 90s, and I used to see long lines of optical fiber has been laid around the country. I do not understand why would they go so much of cable, whether this connectivity will last, and how is it this is going to work, and so on. There are many people ask this question, but that has created an internet revolution. So only through this connectivity, we saw a complete shift from people going to shopping, they become an online shopper. People who is going to theater, they are viewing the pictures at home. People who are traveling to various places, they for various conferences, they were able to use internet and converse on a VC. Today, I'm not in Calcutta. I'm able to speak from here because of the vibrant internet infrastructure. So that was another disruption which changed the world. Then third disruption, which I would like to say, is the business models. Uber was one of those greatest disruption in the recent times. You know what happened? A company which came in without owning a single car, without owning a single driver, without owning any fuel, nothing. They just developed an application called Uber. This application, one can hire a taxi at any place, anywhere. So all you do is you have to give your location and where you want to go. The location is always observed because of your situational thing. And where you want to go, just fix it. The GPS will tell how much is the distance and what is the cost. Then the taxi comes and the driver number comes and he stands before you and you get into that car. What happened? This has disrupted the entire the gamut of taxi businesses, various business houses which were involved in travel. Everybody has been eliminated from the field because of one particular application. So you can see the wonderful, disruption power of science. When the moment a thing is invented, yeah, technology is being taken, how it was sweeping. The other revolution is IoT and artificial intelligence. IoT is nothing but Internet of Things. What is Internet of Things? Internet of Things is that you interface a system. For example, a temperature. What you do is you keep a thermocouple and monitor the temperature. And this is temperature monitoring. This is a simple instrument, but this instrument is connected through a sensor and a data logger into the internet. So that position and temperature is observed through the internet. Now it is a medium for connecting the whole world. This is what is all about IoT. IoT is a system or a particular device that has been connected to the internet through a medium. That's all about IoT. This IoT has made a lot of change, a tremendous change. See, when I had the rare opportunity of visiting to Antarctica. When I went for the Antarctica mission, I found so many scientists were sitting and observing and working and all that. This was in 2004. My friend very recently went and he came back and said, many other scientists have disappeared and they are putting entire systems. So we see only systems, we can't talk to people. So what happens here is this IoT and the artificial intelligence, which takes it over the world. Let me explain you about artificial intelligence, which is something people talk, which is a little complex. But let me tell you a very simple thing. See, the robots we have seen for years. See, in my lab, in my Plymouth lab, we built one of my co-professor by name Guido has been innovating robots and AI for the last 30, 40 years. And he built one beautiful football ground. The football ground, the players are the robots. They will be playing and you can watch the game. It is fantastic. It is as good as what you watch in a soccer game. Of course, there man with life is running here, man without life, but he replicates the human being. See, in the early part of it, robots playing, I could see it's trying to kick the goal. If it misses, it runs back to the position. But today, the robot, what my friend has created, it kicks the goal, but the ball did not go into the goal, but it was hit on it was a bad miss hit on the pole and it got diverted. This robo just felt like a player, and then the camera goes close to the robo, and I could see an expressional change. The robo starts feeling, a kind of expression it gives in the face. This is what is all about artificial intelligence. This is where the whole globe is looking at it. The kind of AI which is being, spreading around the world. It is something phenomenal. I think that in 10 years from now, I'm too ambitious. In 5 years from now, we cannot work with AI without AI. So AI will be part of us. You know what happens? Human interventions will be completely taken over by the systems and AI, and we will be largely involved only in building our systems. I mean, we will be sitting behind and trying to work, and all that which is what today the human beings are doing will be changed. I'll give you a beautiful example. I went to the Mercedes, manufacturing plant in Germany as a part of Siemens team. I was devising some equipment for quality control for Mercedes, so I went to meet them. When I went to meet them, I have seen hardly few executives. When I went into the plant, there is no human being, entirely robot driven. This is what people call Industry Revolution 4.0. This is going to catch the whole world now. I think Germany has gone close to about 74% in Industrial Revolution 4.0. We are primitive, but we also have to catch up Industry Revolution 4.0. Future, your pharmacology, everything will be more data driven. Human only think the need. We have to only do the need statement. Rest of it, the robots will start making. The artificial intelligence will take over. This is going to be another disruption. And lastly, I would talk about adaptation curve. When television was invented, it was invented way back 1945, whereas the television came into existence in all the countries will be about 75, 80, 90 like that. So it took about 40 years for an adaptation of a technology, a creativity came into existence. Whereas today, this technology, what I was talking about, that this picks up at a rampant speed. You look at the mobile phone and the smartphone. Just about 2 years, smartphone zoomed. The way that each of these technologies is catching up very fast. So don't ever be very complacent. It takes us for a very quick ignition. So readiness and artificial intelligence makes a lot of sense. Let me come into how AI can augment the healthcare. See, there is always a big issue with the health sector. We are not connected end-to-end visibility. We have silos of operations. Nothing goes in an interconnected, neat running. We always go through a silos of process. See, a pediatric man, a person who connects with geriatric, the person who's connect with general medicine, surgical oncology. You talk about all the specialty. There is no end-to-end visibility. If you want to go, this one person who may be a general physician will be attending to a patient. He will try and think which area he wanted to go, and based on that, you have to go each domain, and they curtail with whatever the prognosis, diagnosis, and treatment, and then they send back to you. So today we have got an end-to-end visibility by interconnecting each of these domains. So when a patient walks in for any treatment, his whole of his system has been completely monitored, and where all he moves, what all he does, where he gets what kind of a treatment, and whether that treatment is required, everything is quantified through a computing system. So the system drives most of it. Tomorrow, I'm very confident. Sooner or later, general diagnosis is not going to be doctor's subject at all. It is going to be diagnosing AI. So I have seen a couple of AIs now, programs which are going rapidly. As if you look at the Peter Danson statement, he says medical knowledge is doubling every 73 days in post 2020. So from now, every 73 days, our medical knowledge and artificial intelligence development will go double. What you achieved over so many years will be doubled in every 73 days. Look at the kind of enormous progress which is happening on technology. So I think maybe a lot of young students will be listening to my lecture today. My humble request to all of you, be more techy. Now it is no more technology is for engineers. It is for doctor. It is for pharmacologist. It is for everybody. So today the medical school in the Harvard and host of top schools, they recruit students who have got their bachelor's in computer science. Bachelor with computer science, they recruit for their medicine program. You know why? They think these are the guys will be able to manage tomorrow's growing techie based medical care. So this is very important point. We all have to definitely note down. And the demand forecasting, inventory management, whatever I did previously, it was quite good in 1994, but it is not good at 2020. Today we are making demand, forecasting, inventory, all of the logistics will be put in one nutshell, and that drives the whole thing. You don't have to depend on any of this. Then you all must know about industry automation 4.0, where everything is intelligently automated. So no system which needs to get a kind of a human intervention. It goes automatic. See, from one point to another point. See, for example, if somebody wants to manufacture a car, they just have to press number of cars, what model, and what kind of, how many of them belongs to what color, and what kind of, the cars. You have got various varieties. So you can choose the type of cars within the model. All you have to feed in and click a button. Industry 4.0 will produce car and throw it out of the delivery. It is not the way each of these commodity one had to move in and see. No, it does beautiful welding. precise welding. So now you all must have been watching in the last 10-15 years, there is no breakdown. My car broke down, nobody comes. If they come with an excuse, they may say, I'm sorry, I got into traffic, or they may say I have a problem in somewhere diversion and all that. But nobody comes up and say my car broke down, because the car breakdown is become impossible. The breakdown has never been heard of. How did they do it? They do it through the revolution, industry revolution 3.0 to 4.0. Lot of work is put on developing this quality management. So this is another important point. So quality management, which really matters a lot. And see, maintenance also, all along, we have been doing maintenance based on number of days, number of weeks, and so on. Now it is more a predictive maintenance. Every system that is working, they just monitor the data comes out of the system. How many prints it has done, how many scans it has done, and how much hour it worked, and what kind of bulb we used, what is the longevity of bulb. Everything is monitored through an automated system. So the system will throw the bulb you may have to replace within a week. Then you have to replace. You don't have to wait till the bulb fails and come back and do that. So the system runs all the time. So overhauling everything becomes so easy and excellent. So that is where the predictive maintenance work. Then protecting integrity of supply chain. So any supplier you will be able to protect completely. End-to-end protection is given. So no supplier can ever play around any kind of nonsense. If you look at the picture here, this is about the blockchain. You will be able to know. I'm sorry. Are you all able to see this blockchain picture completely?
Yes, sir. Yeah, it is visible
Do you all
there.
see this picture? Excellent. So this is the blockchain as I was talking about. Blockchain. The blockchain is one of the very great technology which people talk very much in India and the overseas. Let me explain. Those of you who know about this blockchain, I would like to explain about it. This is actually Satoshi. Satoshi has developed this. Professor Satoshi of Japan. He has built this blockchain basically for the bitcoins. So the bitcoins, when they make bitcoins, they've created a block of protective chain. What happens here? Every transaction is going through various miners and people who are involved in this transaction. So, for example, in a normal system, if you in the banking system, if you want to send $100 from Chennai to Los Angeles, all I do is $100. I'll go to the bank and send it to them. So the bank takes its charge. It may take $5 out of it and gives $95 to the person whom I'm sending. But now in the blockchain, there is this takes this $95 and it marks on the ledger. There are ledgers, open ledgers. Who all are involved? This person who is sender is involved, and the person who gets this dollar, receiver, is involved. And if there is an intermediary who wanted to involve, you can put them, all of them. So all of them will be in the opening their ledger, and this transaction will go through. In all these computers, the entry will exist. So if somebody wants to hack, they have to hack all the entries, which is impossible. So hacker cannot play around the fool. Number two, there is no bank involved. The blockchain directly will market back to the other person. So what happens? This moves directly. Then there is no commission or charges will ever come in. Even let us say if there is a charge, you can put 0.5. That is 50 cents instead of $5. And these people who are involved, who have certain interest in the system, then they themselves will give the computing power. So you don't have to have a computer to do that. Then you don't have anybody to be employed to monitor all this. So this is every block of transaction. There is a complete protection. They use hash 256, which is nothing but 256 bits of security. So a transaction moves with the security. So this classical flow of this is called blockchain. So the blockchain has become a fundamental engineering. When you talk about blockchain, blockchain always associate with AI. So AI and blockchain are called the twin technologies. So this technology is so fundamental. Today, everybody is moving into blockchain. So I have recently worked for a company called Merslines, which is one of the world's largest liners. They have an asset of about 55 billion dollars asset, and they make a revenue of 5.5 billion every year. And this company was previous. This is the largest liners in the world. Earlier, any ship which gets into the dock, they have to have the entry. There are about 30 to 40 entries they should do. 30 to 40,000 entries it has to do before the ship leaves. Earlier, they used to have a huge manpower, and they make each one of them make small error. All that was happening. Today, we connected through a blockchain. So every ledger is open. People are in different part of the world. They work for this company and they approve it, and things flows in. It's the only company which made profits in the last few years despite all the ongoing trouble. Even the liners have got prices which are existed in 1984 till date. It's not been revised, but still this company survives because of its brilliant IT and blockchain into that. I was involved in that. It's a great exercise I've done, but I gave a very clear, open understanding as how this has been working. So today, for technology, it becomes an operating system. Blockchain becomes an operating system, and it gives the transparency for among the people who involved. So transparent, and nobody can lie. Instead of there used to be functions earlier. He will have only $10 in the bank, but he will give $100 check, and this man will take the check, go present in the bank, and then it gets rejected. But today in the blockchain, one cannot give. If they have $10, they can give only $9 or $10. They can't give $11 because this transaction will not be accepted. So nobody can cheat one another. So that is another great protection. So this is a technology which is happening in the entire health sector. So I would like to give you a small medication movement. This is how the blockchains are being done. See, there is a verified pharmacy, then the verified distributor, and the source. So all this manufacturer, all this is linked to a blockchain. So when the moment the pharmacy places an order to the distributor, and distributor places an order to the manufacturer, the whole process is interlinked. So all the three of them will see what is happening. So there is nothing called hidden transaction here. Everything is open-ended. So the moment you place such orders, you will know when it is going to come. And where is the problem? If there is a manufacturing plant, it delays the production on certain conditions. The pharmacy will know this may take 3 months time, so that they can go in for another intermittent purchase, so that they don't run out of stock. So all this is clearly seen and verified. And number two, many of the fake drugs, what happened from the manufacturer, then to the verified distributor, then to the pharmacy. Fake drugs can enter in various forms. Since this transaction is a complete flow of chain, nobody can intervene, nobody can break the chain. So that is a phenomenal advantage in terms of that. So this is going to be, this blockchain is going to be a movement, and this is going to exist forever. These are the artificial intelligence in healthcare can be deployed in virtual assistants for staff, and automated imaging and diagnostics. It has come with AI. Robot assisted surgery comes with AI. AI in pathology, cyber security of application of healthcare, because health data is so very important after coming after the introduction of insurance system. unless you have a cyber protection, it becomes a major problem. So that is taken care. And the medication, they do a lot of AI and ML, machine language and AI have come into medication management. As I told you earlier, Peter Danson, the amount of data which is coming is so huge. So everybody has got a huge amount of data. Now, earlier we talk about a few terabyte of data. Today, it is going close to a picobyte. I don't know when it's going to be zettabyte. So it starts, advancing so much. The data population is so much. So what happens? Large company, rich company takes over the data arbitrage. So we have to be very protective. India, whatever research you do, you got to be very protective. You put your data in a proper format and try to store in the cloud, and so that you can protect your data. Otherwise, tomorrow to buy back your data, you may have to spend a lot of money. I think the time is running out. I quickly tell you the kind of potential for various applications. See, the cyber security, the robo-assisted surgery is a 40 billion market. So the market is huge. So I wish every of you, I mean, those who are in the discussion today, try to keep thinking, trigger your mind. Trigger your mind and try to be, more and more, active and start going into everything. So that makes a lot of development in yourself. 1 minute. I think I hide the whole listen. So now this becomes the whole, I mean, artificial intelligence is going to create jobs. It's going to build a lot of opportunity and so on. So from the legacy working, we all have to move into technology based. So every research which is coming out is based on technology. Every product which is successful in the globe today, which are getting values of 3 billion, 4 billion, is all based on technology. Without technology, nothing moves. So in particular health, the technology is taking over so much. See, I could see every 10 days I see a large company goes for an IPO. They get hugely funded in the Bay, in the Silicon Valley. You know why? Health systems are becoming so popular. Now about the drug quantification and drug study, everything has got a very huge value in the world over. So try and shift yourself, getting into this field of uh, completely on technology based. So I think I would like to end up my discussion because it is 3:05. Any questions, I would love to answer.
Yeah, it was a wonderful talk, Professor Arumugam. We all enjoyed the talk of what is the AI, how the ruling the technology and the futuristic aspect, and mainly in the supply chain management in the healthcare sector, how it is going to be in the clinical aspect also. So I believe that everyone they enjoyed our talk. We are associated with that all our faculty members sitting over here because of the camera is that focusing here. Everyone is sitting in the conference hall, so all are listening. Okay. They were happy with that, understanding that the concept. And I called our one of our young faculty, Dagit, to summarize that the observations. So over to Dagit.
Thank you, sir. Thank you very much, sir, for your wonderful, interesting, and knowledgeable talk to our audience, to us as well. You discussed the several aspects of AI using D-Logistic, a comprehensive logistics suite, and by which there are different modules are available. By that, you are able to like forecasting the things, bid processing, ordering management, supply monitoring, quality control, stock management, and like barcode system, billing processing, Like that, there are so many applications are developed by this tool. And you discussed then 5 important disruptions that has arrived in last 100 years, like Kodak camera, internet, business models like Uber, Ola, and AI, so many on. Now this AI has going in the area of the healthcare, how this is affecting the healthcare system. Like Peter Dunson said that every 73 days we are getting information double. And now they are able to discuss the smart commerce blockchain, and that's indicate how we can flow of the goods without any problem, and no one hackers can create any problem. Then you discuss the AI in the healthcare, like how it can assist the staff, image diagnosis, detect the cancer, and so many other applications. In addition, AI is growing every day by day and is creating so many jobs to everyone, but it has some barriers like ethical problems are there. It may lead to the job of the loss to the people, to the human beings. With that, I thank you very much, sir, for presenting this wonderful talk.
Thank you. Thank you so much. Any questions from anyone?
Any questions from the audience or faculty? Please. Yeah. Please.
Good afternoon, sir. Sir, you are saying one question that nowadays US university they are hiring computer science graduates. So for all also in our pharmaceutical or other branch also they are keeping computer science as a mandatory now.
No. Actually, what happened is top university, Ivy Leagues, they give more preference for a person who comes from medical or subject which is relevant to health. They prefer people who have got computing science as their background, or the subjects that they have done. They must have done maths and computer science. You know the advantage, because the medical system is moving towards huge technology change. So to adapt those change, one must have the kind of background. Otherwise, they can't adapt the change. So that is why it becomes mandatory.
Any other?
So thank you for this wonderful talk. I have only one question. Like you said that AI is taking over the healthcare sector, and especially in case of diagnostics.
Yes.
So maybe in future also it will take the place of prescribing medications. So what do you think? It's just a general question. Will be the future work of a doctor?
Well, that's a very good question. Actually, the future of the doctor, he will be working with the machine. What happened before, in way back about 10 years ago, I know robotic surgery becomes an option. Today, robots are being largely used for bypass surgery. For most of the surgeries they use. So what happens here? The robots are used, but the robots are being operated by a doctor. So ultimately, the need of a human being is required, but more precisely, a system will do. For example, if I ask you to multiply 5 into 10, you will multiply. 55 into 20, you will multiply. If I start 5,577 into 5,325, then you will fumble, because human beings are capable of certain functions, but they can't do rudimentary and tough exercise. So that is where systems are being done. And system, if a computer can multiply 5 by 5, it can multiply 5,700 by 5,700. Same time I can throw the answer. So that is the beauty of a system. So the complex surgeries, doctor has to, complex surgery has to be given to a robo and program it in such a way that does it very comfortably, so that there is no minimal error, there is no error, zero error, not even minimal error. So the patients get advantage. That's the beauty of systems being adopted inside. See, for example, if you go to a doctor, he will be a very experienced person, but he may ask 10 questions. 2 questions he would have missed. He might not have asked you, are you allergic to any drug? You develop any allergy to drug? Whereas a computer, all the 12 questions will be asked and there won't be anything missed. So there is a human being is intelligent but not error free. Computers are absolute error free, they are not intelligent. So artificial intelligence also is nothing but we program the computer, our knowledge, to perform without mistakes. So that is where this is going to go. So doctors will not lose, but they will be more efficient. We may not need the number of doctors what we produce.
Okay, thank you, sir.
Dr. Arumugam,
Yes, sir.
Chairman, please.
it is just a comment. So I'm really delighted to learn from you the great details about artificial intelligence. Particularly in the current time, the healthcare system is gradually getting converted into different dimension due to artificial intelligence. You have already pointed out regarding pharmacological aspect, regarding diagnostic and clinical aspect, whatever you have just commented, that is a brilliant comment. Diagnostic has been greatly replaced by artificial intelligence, no doubt about that. And clinical medicine, clinical work, including major surgery, that is being gradually taking the help of artificial intelligence over a decade. So the role of robot was limited 10 years back. But now for major surgery, cardiac surgery, vascular surgery, very complicated procedures, doctors are behind the screen, sitting outside on a computer, on console, and the surgery is getting performed on the patient. The main advantage is translatability and the learning curve. There is no mistake. So it can be learned easily. Role of human being cannot be finished. It will be there. But it will change. As you have pointed out, it will change. It will be database. It will be error-free. So clinical medicine is going to take a different shape in coming future, and doctors must be ready. Nobody is going to lose job, but they have to reorient themselves. So thank you very much for this brilliant lecture. It is highly learning for all of us. Thank you.
Thank you so much, sir. Very kind of you to have attended my lecture. Thank you, sir.
Any input, any query from the audience, the students, scholars are there? Thank you, Chairman. Wonderful observation and interaction. Thank you for your time. We come for the conclusion. On behalf of our BOG and the faculty, the audience, the scholars, we are very much thankful to Professor Arumugam for very interactive, inspiring the talk delivered on that artificial intelligence on the supply chain management and how it is going to useful for them, the futuristic aspect, application orientation. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you. Thank you.
Thank you. Thank you.